Welcome back to this next video in which we are studying headaches. Okay, so we've now finished our discussion of tension type headaches, and I'll stress once again that tension type headaches are the most common type of headache. This is the normal type of headache. This is the type of headache that you get if you've had a very stressful day and then at the end of the day you're suffering from a headache. It's also the type of headache that you get when you've got a cold or the flu or a tummy bug, and you get a headache as an accompanying symptom of that. That type of headache is a tension type headache, most likely. Okay, we're now going to move on and discuss another type of primary headache, the second type of primary headache that I want to discuss in this video, which is migraine headaches. So let's just move down to a fresh portion of the board down here, and I'll just put migraine as the title here. So my first warning regarding migraine headaches is that people use this term in normal conversation often inappropriately. People use the term migraine as though it is synonymous with headache, and people love to do this. They love to say when they've got a headache that they've got a migraine, and they think that migraine means the same thing as headache. It does not, and most of those people telling you that they've got a migraine will probably have a tension type headache rather than the actual migraine headache. They might potentially have a migraine headache. Some people might actually be using this term appropriately, and they might actually be suffering from a migraine headache, but often people use it inappropriately and they use it as though it's synonymous with headache, which it is not. Okay, it is a specific type of headache that is rarer than tension type headaches and is far worse than tension type headaches. And most people in their life will not suffer from a migraine headache. I have never suffered from a migraine headache, and I hope it remains that way. You have to have the disorder of migraine in order to be susceptible to suffering with migraine headaches. And the basis for having migraine, having this disorder that means that you're susceptible to suffering from migraine headaches, is genetic, as we'll discuss later on. Okay, so most people will never suffer from a migraine headache and can never suffer from a migraine headache. You have to have genetic susceptibility to be able to suffer from these types of headaches. Okay, so firstly let me just clear up the fact that this term, migraine, can be used in two different ways, as indeed I have just been using it in two different ways, but let me now spell that out. So you can either use the word migraine to mean the disorder, which is fundamentally a brain disorder. It's a problem with the brain that leads to you developing a migraine headache. So we can use this term migraine to mean the disorder that means that you are susceptible to suffering from migraine headaches, and that disorder is for genetic reasons. It's because of your genome. We can also use the term migraine to actually mean the migraine headache. So you can say either that someone suffers from migraine and that means that they have the disorder, which means that they are susceptible to suffering from migraine headaches, or you can say that someone is currently having a migraine and that means that they are currently having a migraine headache. So there are those two ways that we can use this same word. We can either use it to mean the disorder where you are susceptible to suffering from migraine headaches, or we can use it to mean the actual migraine headache itself. So that's the first thing that I want to clear up. Next, let's talk about the epidemiology of migraine headaches. How common is it to actually have the disorder migraine where you are susceptible to suffering from migraine headaches? Well, it's not uncommon. So it is plausible that when someone comes up to you and says, I've got a migraine headache, or I suffer from migraine, that they actually are telling the truth, that they actually know what they're talking about. So, how common is it? Well, it's 1 in 5 women who suffer from migraine, and it's rarer in men. In fact, it's 3 times more common in women compared to men. So a little bit of maths now, that means it's 1 in 15 men. So 1 in 5 women suffer from migraine and 1 in 15 men suffer from migraine, this disorder where you're susceptible to suffering from migraine headaches. Right, so a big thing that I want to do now in my description of what a migraine headache is actually like is to contrast it to tension type headaches so that you really understand what the difference between a tension type headache and a migraine headache actually is. And I think one of the ways that I can really convince you about how different these two things are is by giving you a little taster of the pathophysiology of migraine headaches compared to the pathophysiology that we've studied of tension type headaches. Now, we will go into detail later on about the pathophysiology of migraine headaches, and it is very, very satisfying. There's a very, very beautiful theory of what happens when you develop a migraine headache. I mean, it still has holes in it, but it's a very, very beautiful theory nonetheless. But for now, let me just give you a little taster of the pathophysiology of migraine headaches to show you how different they are compared to tension type headaches. So, with tension type headaches, we have discussed that the pain, we believe, actually originates from nociceptors that are in the muscles that are in the head. So the frontalis muscles, the temporalis muscles, and the occipitalis muscles. Now those are all extracranial sites. Those are muscles outside of the skull. And therefore, we believe the pain in a tension type headache originates extracranially. It originates from the activation of nociceptors that are located extracranially, outside of the skull, in those muscles. Now, in migraine headaches, rather, we believe that the pain is going to originate from the activation of nociceptors that are located intracranially rather than extracranially. Now, where are the nociceptors located intracranially? Well, most of the brain parenchyma is not actually innervated with nociceptors. Most of it does not have pain neuron innervation at all. And the biggest piece of evidence that I can give you for why we know that's true is that contrast a heart attack, a myocardial infarction, to a stroke. In a heart attack, we'll start by comparing them. In a heart attack, what happens is a great big lump of the heart muscle dies because of insufficient blood supply. In a stroke, a great big portion of the brain tissue dies because of insufficient blood supply. So it's the same thing in different locations. However, what happens when you have a heart attack? When a great big part of the heart dies, you get absolutely agonizing chest pain. You get a characteristic crushing chest pain that a lot of people rank as the worst pain that they've ever experienced in their life. Now, when you have a stroke, when a great big portion of the brain dies, you can get massive neurological symptoms. I mean, you can lose the ability to talk properly. You can lose the ability to move half of your body. You can get horrendous neurological symptoms that show you that you're having a stroke. However, you do not usually get pain. And that's because the brain parenchyma that is dying is not actually innervated by nociceptors, whereas the heart muscle is innervated by nociceptors. So when a great big part of the heart muscle dies, it activates those nociceptors and you get the agonizing, crushing chest pain, whereas when a great big lump of the brain dies, there's no nociceptors to activate. So there's my piece of evidence for why most of the brain parenchyma is not actually innervated by nociceptors. So where are the intracranial nociceptors? Well, it's in the meningeal layers that surround the brain, the dura mater, the arachnoid mater, and the pia mater. We will discuss the anatomy of the meninges later on when we come on to the pathophysiology of migraine headaches in full. But those layers are innervated by nociceptors, and they're the major site of intracranial nociceptors. So, in a migraine headache, it is the meningeal nociceptors that are going to be activated and which will give rise to the actual pain of a migraine headache. So there's a big difference between tension type headaches and migraine headaches. In tension type headaches, the pain originates from the activation of extracranial nociceptors that are present within the frontalis, temporalis, and occipitalis muscles, whereas in a migraine headache, the pain originates from the activation of meningeal nociceptors that are intracranially located. So the pathophysiology is very, very different, and in migraine it's fundamentally something occurring in the brain, a phenomenon called cortical spreading depression that is going to lead to the activation of those meningeal nociceptors. So again, I will stress that migraine, the disorder of suffering from migraine headaches, is a disorder of the brain, and we'll understand that disorder of the brain later on. Right, so there's a little hint as to what's going to come in the difference between the pathophysiology of migraine headaches and the pathophysiology of tension type headaches. Now let me actually give you the description of what a migraine headache actually feels like, and again we can see the massive difference between the actual experience of having a migraine headache and the experience of having a tension type headache. Now, for those of you who know something about migraine headaches, you will know that sometimes they can be preceded by something called an aura. We will set that to one side for now. We'll come back and discuss the aura. At the moment, I just want to describe the actual migraine headache itself. So, we've done epidemiology. Now, let me start by describing the severity of a migraine headache. So, when we were discussing tension type headaches, we said that the severity was mild to moderate. That's how we graded the severity. Migraine headaches are going to be more severe. Their grade is going to be moderate to severe, so upper whole level. So the severity of a migraine headache is going to be moderate to severe, so it's a much worse pain than we had in tension type headaches. Next, that's severity done. Now let's discuss the site of the pain. Now, again, let's contrast it to tension type headaches. In tension type headaches, the site is usually bilateral and it was often in the temporal regions, although it could spread into the frontal region and the occipital region, and therefore it would surround the entire head. In migraine headache, the headache is usually just on one side of the head. It can be on both sides of the head. It can be bilaterally. However, it's far more normal for it to be unilateral. So a migraine headache is usually just on one side of the head, whereas tension type headache is usually on both sides of the head. So it's on one side of the head, but which regions of that one side of the head is it generally in? It's usually in the frontal region, so the forehead region and the front of the scalp region. It can also go in the periorbital region and into the temporal region. So let me put this in here. So the regions that it's generally in are the frontal region on that one side, and then also the periorbital region on that one side, and then finally in the temporal region on that one side. So, for instance, if we were suffering from a right-sided migraine headache, a migraine headache on the right side, it might be in the right forehead, the right front portion of the scalp, the right temporal region, and the right periorbital region, this moderate to severe pain. Now, another important point for me to point out is that migraine headaches, they are usually unilateral, but it doesn't need to be the case that all of the migraine headaches a certain person ever suffers from will always be on the same side. They can move between different sides. So if at the moment you're having a migraine headache that's on the right hand side, then the next time you have a migraine headache, it doesn't necessarily have to always be on the right hand side, so it could then be on the left hand side. So although the migraine headache is unilateral, it's not always on the same side, is my point. Okay, so we've done severity, we've done site. We need to now discuss the character of the pain. What does it actually feel like? So remember when we were discussing tension type headaches, we said that the pain had a squeezing character. It felt as though the head was being squeezed, and indeed if it was all around the head, so if it was in the temporal regions, the frontal region, and the occipital region, then it could feel like a band being around the head, pressing in on the head. Migraine headaches usually have a very different character. They're usually pulsating in nature rather than squeezing. Now, what does this then feel like? Well, it means that it pulsates, and it usually pulsates in tune with the pulse. So the pain gets worse and then gets better. You have a moment of relief, it then gets worse again, it then gets better, worse, better, worse, better. And it gets worse every time the heart beats. So every time the heart beats, what happens, of course? The blood pressure goes up to systolic arterial pressure, and all the arteries bulge out. And this, of course, will be happening in the arteries up in the meningeal layers, and that bulging out will lead to increased pain. So when the systolic blood pressure is present and the arteries are bulging out, that's going to make the headache worse. So the headache pain pulsates in tune with the pulse, which was not a feature of tension type headaches. Okay, so we've done severity, we've done site, we've done character. Next, let's discuss the duration. How long can a migraine headache last for? Well, it usually lasts between 2 and 72 hours. So let me put this here. So migraine headache usually lasts between 2 hours and 72 hours. And remember, 72 hours, that's 3 days. Divide it by 24 and you get 3. Now, there is a special term, a nice piece of terminology is coming up now. So if you have a migraine headache that goes on for greater than or equal to 72 hours, i.e. you have been having a migraine headache for more than or equal to 3 days now, we have a term for what you are suffering with. We say that you are currently in status migrainosus. So this is a nice piece of fancy terminology. So if someone has been suffering from a migraine headache for now greater than or equal to 3 days, we say that that person is in status migrainosus. Right, so that's duration. Now, next thing to discuss is accompanying symptoms. So again, let's get another colour. We'll go to a pinky colour now. So accompanying symptoms, hopefully you can already put one on here. What do you think is going to be an accompanying symptom with the headache? And I'm not talking about the aura at the moment, we'll come back to the aura. Unaccompanying symptom is going to be nausea and vomiting, and we now understand how that is going to occur. We understand and have discussed when we were discussing tension type headaches how when you're experiencing pain, there are pathways that are not well understood at all, that link the cerebral hemispheres down to the vomiting center in the reticular formation. And when you're experiencing pain, the cerebral hemispheres can activate the vomiting center so that you start to feel nauseous, and so that you might even vomit if the vomiting center is activated enough. So nausea and vomiting can be accompanying symptoms with a migraine headache, just as they were with tension type headaches, and as they're going to be with all the other types of headaches that we will come on to later on. Now, there is a big cluster of symptoms that I have not previously told you anything about because they weren't relevant when we were discussing tension type headaches, which can now accompany migraines, and these are known as the meningeal symptoms. Now, these are the symptoms that can arise when you get activation of the nociceptors in the meninges, the meningeal nociceptors. So, of course, when you activate the meningeal nociceptors, it's going to create a headache, but it can also create accompanying symptoms, and these are known as the meningeal symptoms. And the reason these weren't relevant in tension type headaches is that the nociceptors we were activating to produce the headache were not meningeal nociceptors, so they don't produce the meningeal symptoms. So, what are the meningeal symptoms then? Well, these are very, very famous symptoms because they're the classic symptoms of meningitis. Meningitis, remember, is inflammation of the meninges, usually caused by an infection in the meninges. We will come on to that later on because it certainly causes a headache. And because that type of headache that meningitis produces is caused by the activation of meningeal nociceptors, it produces the meningeal symptoms. So these symptoms are the classic symptoms of meningitis. However, they are not just the symptoms of meningitis. They are symptoms that can arise whenever you activate enough meningeal nociceptors. So if you're suffering from a very bad migraine headache and you've got a lot of meningeal nociceptors activated, you can get these meningeal symptoms. So let's list off these famous symptoms then. So starting off, photophobia. This means intolerance to bright lights. Bright lights will cause you pain. You will seek to avoid them if you've got meningeal nociceptor activation. So this is one of the reasons that people who are suffering from a migraine headache tend to want to lie in a darkened room where there is no light because they're photophobic. In addition, one that's not quite so famous but is still notable is phonophobia, which is intolerance to loud noises. So you don't like bright lights, you don't like loud noises, and we'll discuss the reasons, or the potential reasons, for the development of these symptoms later on when we come on to pathophysiology. So intolerance to bright lights, intolerance to loud noises. What other meningeal symptoms are there? Knuckle rigidity is another meningeal symptom. So I'll put this here. This is the fancy way of saying neck stiffness. So what happens is when you activate a lot of meningeal nociceptors, a response to that is to increase the tone of the muscles in the neck. So all of the muscles in the neck become hypertonic. They start contracting all together, and this means that your neck becomes very stiff because all the muscles are contracting at once, trying to keep the head completely still. And you can imagine that that's kind of to try and protect the head. If the meningeal nociceptors have been activated, that probably means there's something very wrong in the head, so you don't want to damage the head any further. So keeping the head still is hopefully a way of doing that, and that's one of the reasons that the tone of the neck muscles goes up so much. So you will really struggle to move your neck, and if someone else tried to move your neck, they'd struggle to move your neck as well, and that's called knuckle rigidity or neck stiffness. Okay, and then the final important meningeal symptom is that the headache that you get from the activation of the meningeal nociceptors will be worse. It's characteristically worse with physical activity. So worse with, and I can't be bothered to write physical activity, so I'll just put worse with activity. And again, this is another reason that people with a migraine headache will often just go and lie in a darkened room, because they don't want to be around bright lights because of the photophobia, and they also don't want to be doing anything because the headache's made worse by them doing things. And that's not really a problem with tension type headaches. The headache isn't really made worse by doing things, whereas migraine is made a lot worse by doing things. And therefore it's much more debilitating, a migraine headache. You can't really carry on doing whatever you were doing previously. If you're at work, you really can't carry on, because if you continue to carry on, the headache's going to be just made worse and worse and worse, whereas that's not so much of a problem with tension type headaches. Okay, so these are the meningeal symptoms. When you've got a headache that is due to the activation of meningeal nociceptors, you will often get these accompanying symptoms. And there is another term that people often use for when you've got a headache along with the meningeal symptoms. People often describe that syndrome, that collection of symptoms, as meningism. It's a term that you do see used. So meningism is, if you like, the syndrome of having a headache with the meningeal symptoms that therefore suggests that the headache is due to the activation of meningeal nociceptors. Right, so there we go. There are the accompanying symptoms with migraine. And let me stress that the more activation of meningeal nociceptors you get, the worse will be the headache, the more you will have the meningeal symptoms. So you have to get a lot of activation of meningeal nociceptors to get these symptoms to a notable level. I mean, when you get meningitis, you get massive activation of the meningeal nociceptors, hence why you get really, really prominent knuckle rigidity and photophobia and phonophobia, and the headache made worse by doing anything. With migraine headaches, you're not going to necessarily get as much meningeal nociceptor activation as you would in meningitis, and therefore these meningeal symptoms won't necessarily be as profound as they would be in meningitis. Okay, so a few more little pieces of terminology or little bits that I want to add into the story here before we then discuss the complicated bit, which is migraine auras. Okay, so firstly, there is a piece of terminology that is very analogous to a piece of terminology that we've previously seen, which is the piece of terminology chronic migraine. What could this mean? So we saw that chronic tension type headaches meant that you suffer from tension type headaches on more than or equal to 15 days per month. The exact same definition is used for chronic migraine. So if you suffer from chronic migraine, which is an absolutely horrible condition, then you're going to suffer from migraine headaches on greater than or equal to 15 days per month. So chronic migraine is often abbreviated down to CM, like chronic tension type headache was abbreviated down to CTTH, and this means that on more than or equal to 15 days in a single month, so 15 days per month, you are going to be suffering from a migraine headache. Right, another final little thing that I want to add on here is that just like with tension type headaches, you could get cutaneous allodynia in the region where you got tension type headaches. If you're having them very, very frequently, you can again get that if you're having very, very frequent migraine headaches. So let me just add this in this little space here. So you can get cutaneous allodynia. So if you're having very frequent migraine headaches, and let's say they commonly affect a certain area, so let's say you commonly have right-sided headaches that are in the frontal region, the periorbital region, and the temporal region on the right-hand side, and you're having them very, very frequently, what you can actually end up with is cutaneous allodynia in that area. So you can end up with, in between migraine headaches, having pain in those regions if you just touch those regions. So stimuli that should not give rise to pain are giving rise to pain. And you might, if you're on the ball here, you might think, well, how on earth is that going to work? Because we saw the mechanism of cutaneous allodynia in tension-type headaches. It involved the sensitization of the synapse between the primary nociceptive afferents that innervated those muscles, the frontalis, temporalis, and occipitalis muscles, and the second-order neuron that would relay the information up to higher places. Now, that sensitization occurred because of the continuous, because of the high level of activation of the primary nociceptive afferent and the common scenario that was happening, that it was successfully activating the second order neuron. But now, why is this going to occur? Because the nociceptors that we're going to be activating in migraine headaches are very different. They're not the ones anymore that are in the muscle tissues extracranially. They are intracranially. So how on earth is this going to work? Well, it is, and we'll come on to the mechanism later on. So you can get cutaneous allodynia in the regions over where you actually feel the pain in a migraine headache, despite the fact that the pain is arising intracranially rather than extracranially. And we'll discuss how later on. Okay, so now to cover the difficult bit in the explanation, to discuss migraine auras. So get the red pen at the ready, and I'll put the title. We're now going to discuss migraine auras. Okay, so this is a complicated topic. It will make a lot more sense when we've actually discussed the pathophysiology, and believe me, the pathophysiology, our current theory of this, is absolutely beautiful because it explains all of this. Now, what is an aura then? An aura is a collection of neurological symptoms that can precede a migraine headache. Now, not everyone who suffers from migraine will actually suffer migraine headaches that are preceded by migraine auras. In fact, it's only a third of people with migraine will actually suffer from migraine headaches with preceding aura. And we therefore divide migraine into two different types. So we say that people who suffer from migraine headaches with no preceding aura, we say that they have migraine without aura. And I'll just put this here. So migraine without aura is one form of migraine, and that's what 2/3 of the people suffering from migraine headaches will have. They'll have migraine headaches, but they'll have no preceding aura. And then this other 1/3 of people, they suffer from what we call migraine with aura, which is the name for the disorder again. It's the name for the disorder of being susceptible to suffering from migraine headaches with a preceding aura. Okay, so 2/3 of people suffer from migraine without aura of the people who suffer from migraine, and 1/3 of people suffer from migraine with aura. So we understand what happens in migraine without aura, exactly what we've just discussed. You get these types of headaches from time to time. Now let's talk about migraine with aura, which is 1/3 of the people with migraine. So in migraine with aura, preceding the migraine headaches, you get something called an aura, which is a collection of neurological symptoms. And this aura can last between a few minutes. So how long does it last? It lasts from a few minutes to a whole hour. So from a few minutes to 1 hour is how long the aura lasts. Now, what sort of neurological symptoms do you actually get then in a migraine aura? Well, it's very, very often visual symptoms. So I'm going to describe this one first, and then we'll come on to rarer types of aura. Now, these auras, they precede the actual migraine headache, and they are a giveaway sign to someone who suffers from migraine with aura that they're about to suffer from a migraine headache. So they last for a few hours, for a few minutes to an hour, and then after the aura is beginning to end, that will be when the actual headache starts, the migraine headache starts. Other people who don't have auras, people who suffer from migraine without aura, they will just get the headache starting. They won't have this collection of neurological symptoms preceding it. So let me just get a another colour to use. So let's start by discussing the most common type of aura, and this is the type of aura that nearly all of the people who suffer from migraine with aura actually suffer from. Another thing that I should just point out is that if you suffer from migraine with aura, it's not the case necessarily that every single one of the migraine headaches that you ever get will be preceded by an aura. Some of them may be preceded by an aura, whilst others might not be preceded by aura. So it is variable. People who suffer from migraine with aura, it's not the case that every single migraine headache they have is always going to be preceded by an aura. It can change. Okay, migraine with aura is just the condition of being susceptible to suffering from migraine headaches with a preceding aura. So let's start by discussing the visual aura, which, as I say, is the most common type of aura. This is nearly everyone who suffers from migraine with aura, this is the type of aura they will have. So, the normal phenomenon that they get is something called a scintillating scotoma. So, let me just make sure I spell this correctly. Scintillating scotoma. And this may sound absolutely ridiculous because of the alliteration there. However, it is actually a reasonably good name for what actually happens. It describes very well what actually happens. So I think before going any further, I'm just going to actually describe to you what a scintillating scotoma is, and then we'll discuss it a little bit more. So, this is a visual disturbance. So what I need you to do is imagine dividing the visual field up into quadrants. Imagine putting a vertical axis down the middle of the visual field and a horizontal axis through the middle of the visual field, so that we have divided the visual field into 4 quadrants. And I'll just draw this here. Okay, so this is the right superior quadrant, this is the right inferior quadrant, this is the left superior quadrant, and this is the left inferior quadrant. Now, scintillating scotomas usually occur in just half of the visual field, i.e. in a single visual hemifield. And when we discuss the pathophysiology, you'll understand why that visual hemifield that is affected is usually the opposite side to the side that the headache is going to develop on. So we've discussed the fact that the migraine headache is usually unilateral, so it's usually just on one side. So let's imagine that we have a right-sided migraine headache. If that was to be preceded by a visual aura, the visual aura would usually be in the left visual hemifield. And hopefully you can understand this, because remember, the right cerebral hemisphere, that controls everything that's on the left. Its visual cortex controls, processes the left visual hemifield, and everything's contralateral, remember. So if we're getting pain on the right-hand side, you would expect that to be affecting neurologically the left-hand side. And indeed, it will all make sense when we discuss the pathophysiology. So let's show on my picture then a left visual hemifield scintillating scotoma. Of course, the headache can be bilateral occasionally, and if it is bilateral, then the visual field changes may well be bilateral, which I'll discuss in a moment. So, a scintillating scotoma. Scintillating means sparkling. Scotoma means blind spot. So this is actually a very good name for describing what's going to happen. So the phenomenon starts right at the centre. You start by seeing bright lights at the centre, like so, and we're doing the left visual hemifield, so I'm just showing it on the left side rather than on the right-hand side here. Okay, so you see bright lights like this, and this is going to expand out. It's going to expand gradually outwards. So this rim of bright lights that I'm drawing in white here expands outwards like that. So it might grow from being like this to being like this, and then it's going to grow further. So it expands out in the left visual hemifield. So this is the left scintillating scotoma, and it can expand out further and further. So this represents a portion of the visual field where you're seeing bright flashing lights, and that represents overactivity in a certain portion of the visual cortex, and we'll come on to this more when we discuss the pathophysiology. Now, what happens to the bit left behind? So this bright area is expanding outwards, and I should stress that you don't see all of this at once. This is gradually going to turn into these wider hemicircles here. So it's going to expand out into these larger scintillations. what happens in the wake? So as this is expanding out, what happens to all of the visual hemifield left behind, left inside of the bright flashing light rim here, the scintillating rim? Well, that's where you're going to get the blind spot. It's going to either become completely dark, i.e. you'll see nothing in this region, or it will just become very blurry, so you won't be able to see anything in detail in that region. Often it's the case that it just becomes blurry rather than the case that it goes completely black, but it can go completely black. So what happens then in a scintillating scotoma? It's usually just half of the visual hemifield rather than the whole visual field. It's usually just half of the visual field, i.e. one visual hemifield rather than the entire visual field, and you get this expanding region of scintillation. The scintillation expands out, and then in its wake it leaves an area of under-processing effectively. So really, foreshadowing what we're going to see in the pathophysiology, it's overactivity in a certain portion of the visual cortex that is spreading out to other portions of the visual cortex. It's moving which bits of the visual cortex are overactive, and then it's followed by underactivity afterwards. And we'll make this rigorous later on. Okay, so that's what happens in a scintillating scotoma. As I say, it's usually just on one side, and it can eventually grow to fill the entire visual hemifield that it's affecting, and therefore you can end up with half blindness effectively that will go away. It's only temporarily. After the hour's up, it will return to normal. The cortex will recover, but you can end up with a temporary hemianopia, which means that you can't see anything in half of the visual field. In this side, it would be a left hemianopia here once this is expanded right out and covered the entire visual hemifield there. Now, as I say, it could be bilateral, so it could be, you can imagine, joining up all these lines now and expanding out from the centre all over the entire visual field. If it was bilateral, it would usually correspond then to a bilateral migraine headache afterwards. Right, so that's the usual form of migraine aura that most people suffer from, the scintillating scotoma visual aura. Let me now describe rarer forms of migraine auras. So, the next form to describe is the sensory migraine aura. Now, usually, if someone suffers from a sensory aura, it goes along with a visual aura. So, I've said that a third of people with migraine suffer from migraine with aura. Most of those people who suffer from migraine with aura, the type of aura that they will get is a visual aura. They will get a scintillating scotoma. Now, a half of the people who get that type of aura, who get the visual aura, which is nearly all of the 1/3 who do get migraine with aura, they will now get sensory auras. So we're halving the number now. So half of the people who suffer from migraine with visual aura, which is nearly all of the people who suffer from migraine with aura, will then get a sensory aura as well. And usually it's the visual aura that starts first, and then the sensory aura comes on later. And we'll discuss why later on when we come on to the pathophysiology. It's because it usually starts at the visual cortex, and then it can spread forward to the sensory cortex, the primary somatosensory cortex, and the phenomenon that is spreading is a brain phenomenon, the phenomenon of cortical spreading depression. At least we believe that that is the phenomenon that underlies this. Okay, so what happens in a sensory aura? Well, again, the sensory aura is usually just on one side of the body. It's a disturbance in the sensory system this time rather than the visual system. Again, it usually affects one side, and the side it's going to affect is usually the contralateral side to the side where you will get the headache, just like the visual hemifield that was affected was the contralateral side to the side of the headache. Okay, so if we're talking about a right-sided migraine headache, we've been talking about a left-sided scintillating scotoma in the left visual hemifield, and we'll therefore also be talking about left-sided sensory aura. So let's draw a little man here. So here's the head, here are his arms, and here are his legs. Right, so let's divide him in two with a little dashed line down the middle, and we are interested in his left-hand side, so this is his left-hand side. So we're now going to describe what can happen in a sensory aura on his left-hand side. So, again, think of it like this: overactivity followed by underactivity. Now, what is overactivity in the primary somatosensory cortex? If you had overactivity in a region of the primary somatosensory cortex, what would you actually feel? Well, it corresponds to tingling. If you had underactivity in a portion of the primary somatosensory cortex, what would you feel? That will correspond to numbness. So you're going to get a spreading tingling sensation followed by numbness, and it's the exact equivalent to overactivity in the visual cortex causing bright flashing lights, followed by underactivity causing blurriness or even complete blackness. Okay, now it usually starts in the hand region because as the cortical spreading depression moves from the visual cortex, and I'll go over this rigorously later on, it's just a little foreshadowing. As the cortical spreading depression moves from the visual cortex to the primary somatosensory cortex, which bit does it arrive at first? It's the hand region that's sort of right in the middle on the way down of the primary somatosensory cortex. Let me just try and go back up all this way to my picture here. Here's the primary somatosensory cortex. Remember the hand following this, it's sort of nicely in this sort of region. So if it's coming forward from the primary visual cortex, which is right at the back here, you can imagine that the bit it's going to hit first is this bit, and then it'll spread up to these other bits. So usually it starts in the hand. So right the way back down now. Will I find it again? Yes, here we go. Right, so we're doing a left sensory aura, so it usually starts in the left hand here. So you'll start by feeling tingling in your left hand, and this tingling will move up your arm and further up to your trunk, and then it will spread up your trunk and down your trunk. So up to your head and then down to your leg at the same time. And in its wake, as the tingling spreads on and on, it will leave numbness. So tingling followed by numbness is what's going to happen in a sensory aura. You get tingling, spreading, and then after the tingling's gone from an area, you'll get numbness in that area. And that's what happens in a sensory aura. And as I say, often this follows a visual aura. Not everyone gets this. Some of the people who get visual aura just get the visual aura, and it doesn't ever make its way up to the primary somatosensory cortex, this phenomenon of cortical spreading depression. But some people, it does make its way up back to the primary somatosensory cortex, and they then get a sensory aura after the visual aura. All of this corrects. It's only temporary, this change in the function of these portions of the cerebral cortex. It ends, and then what follows is the migraine headache afterwards. Okay, so those are the major two forms of aura, visual aura and sensory aura. I'm now going to tell you about a third form of aura that is quite terrifying, but thankfully is very rare. Only very rare forms of migraine give rise to this. So these are the major two forms of aura, visual aura and sensory aura. This final form of aura that I'm giving you, it's very rare, and I'll talk about the special forms of migraine that give rise to this. So this is motor aura. So you can imagine what's going to happen here. Here it's going to be the primary motor cortex that's going to be affected, and follow the pattern. It's overactivity followed by underactivity. What happens if you get overactivity in the primary motor cortex? Well, you get shaking and tremors. What happens if you get underactivity in the primary motor cortex? Well, you get paralysis or weakness that can go up to paralysis. So again, it usually starts in the hand. So you'll get shaking in this region. It will spread its way up to the face, down to the leg rather, and then in its wake, it will leave weakness, so you won't be able to move that properly. And again, I'll stress this is reversible. It's only temporary. It's because of strange phenomenon called cortical spreading depression occurring in the primary motor cortex. So I will just put here that thankfully this form of migraine aura is extremely rare, and only certain special forms of migraine can actually result in this form of aura. Okay, but it is one still to be aware of that can happen, and it nicely fits the pattern. I hope you're starting to appreciate that there is a pattern of spreading overactivity followed by underactivity in portions of the cerebral cortex that is going to give rise to these auras. Okay, right. So, just a few more things to discuss and then we'll have a break. Things that I want to discuss. The genetic basis of migraine is something that I want to discuss. So, migraine. I've said that most people cannot suffer from migraine headaches. Most people do not have this disorder, migraine. They do not have the susceptibility to suffer from migraine headaches. What is it then that gives rise to someone actually having this susceptibility to suffer from migraine headaches? Why do some people have this disorder called migraine? It's genetic, we think, but it's generally not simply genetic. It's not monogenic. It's not the case that there's one gene, and if you have a certain allele of this gene, it gives you the condition. It's not that simple, unfortunately. We think that there are loads of different genes that all play a role, and if you've got certain alleles in lots of those different genes, that gives you the susceptibility to suffer from migraine headaches. So we think there are a lot of genes that play a role in whether you are susceptible to suffer from migraine headaches or not, and you have to have the right alleles in lots of those genes in order to actually have the susceptibility to suffer from migraine headaches and suffer from this disorder called migraine. The great piece of evidence in favour of it being genetic is that migraine generally runs in families. Often if you've got someone who's suffering from migraine, they all have a positive family history of it. You know, they'll say my mother suffers from migraine, and my sisters all suffer from migraine as well. There'll be a lot of people in their family that suffer from migraine. So it's a disorder that runs in families, and that's because we think that the susceptibility is encoded in the genome, but it is not simple the way it's encoded in the genome. In most cases, it is not monogenic. There is not a single gene responsible for it. We cannot screen your entire genome and say, this is the piece of DNA that is responsible for you having migraine. There will be a lot of different genes that are all playing a role, and you've got the right combination of them to overall give you enough susceptibility. So where can I write this down? And all of that blabber that I've just been spouting, that can be summarised up by a single word that we can say it is polygenic. Multiple different genes play a role here. However, there are rare cases of migraine that give rise to this final type of aura that I've just been discussing, motor aura. So there are very rare forms of migraine called familial hemiplegic migraine. So I'll just bring this up a little bit and we'll put it here. So we've discussed the fact that very rarely migraine with aura can have this motor aura. In people who suffer from migraine with a motor aura, they usually do have a monogenic basis for their migraine, and these conditions are called familial hemiplegic migraine, or FHM for short. So this stands for familial, meaning it runs in families, so it's genetic, and then H is for hemiplegic. Now hemiplegic means half paralysis, paralysis of one side of the body. Now, usually in a motor aura, you don't quite end up with full hemiplegia. Hemiplegia would mean complete paralysis of one side of the body. Usually it's more weakness in that side of the body. So a better name, in my opinion, would have been to call this familial hemiparetic migraine, because hemiparetic means half weakness. Hemiparesis describes weakness in one side of the body. However, it is familial hemiplegic migraine, so we better get rid of that. So familial hemiplegic migraine. And can I just stress, before I explain familial hemiplegic migraine, that all of these forms of aura are generally on one side, and that side is contralateral to the side that the headache will then be on. However, if the headache is going to be bilateral, then it can obviously affect both sides of the cerebral cortex as well, so you can end up with the auras being on both sides, but that would usually correspond to a bilateral migraine headache as well, and we'll understand that completely when we discuss the pathophysiology rigorously. Okay, so in familial hemiplegic migraine, we can, in these people where they have the motor aura, we can look at their genome, and we can find a single gene, and we can point at the allele of that gene that is causing the disease, i.e. these types of migraine, it is monogenic. It's very simple, a single gene is responsible. And these conditions are inherited in an autosomal dominant fashion. So the genes responsible are on the autosomal chromosomes, and you only need one of the alleles to actually get this disease. Now, there are different forms of familial hemiplegic migraine, 3 so far that we have identified, and these are called familial hemiplegic migraine 1, 2, and 3. And later on, when we're discussing the pathophysiology of migraine, or after we've discussed the pathophysiology of migraine, I will tell you which genes are responsible for familial hemiplegic migraine 1, familial hemiplegic migraine 2, and familial hemiplegic migraine 3. And we'll use this to sort of give us a little bit of a clue as to what actually causes this phenomenon called cortical spreading depression. So, each of these is associated with a different gene. Those genes are autosomal, so you'll have 2 copies of each of the genes on the 2 copies of the chromosome, the 2 homologous chromosomes, and each of those genes will have loads of different alleles that you could have in both of those positions, and there will be certain of those alleles that, if you have them, will give you the condition of familial hemiplegic migraine, will make you suffer from migraines with motor aura, and you only need 1 copy of those bad alleles in order to actually get the disease, hence why it's dominant. Okay, but we'll go over the complicated genetics later on. So this is monogenic, so this is very nice. Geneticists absolutely love it when conditions are monogenic. Okay, right, so we'll come back to familial hemiplegic migraine later on. The final thing that I want to say is, what are the triggers of migraine headaches? So we've discussed the fact that migraine, the condition of being susceptible to suffering from migraine headaches, this is genetic, it's polygenic. So you can, it's set in your genome whether or not you have this disorder migraine, whether you are susceptible to suffering from migraines, whether you have a migraine susceptible brain. But if you do have a migraine susceptible brain, what then determines when you're actually going to suffer from a migraine headache? Well, again, there are triggers. There are respected, well thought of triggers that we acknowledge can actually trigger migraine headaches in people who are susceptible to suffering from migraine headaches, i.e. in people with migraine. So let me now put the triggers down here. But again, I'll stress that even if you're exposed to these triggers, if you don't suffer from migraine, they're not going to give you a migraine headache. They might give you a tension type headache, because a lot of these triggers are the same as the triggers that we saw in tension type headaches. But unless you are susceptible to suffering from migraines, you're not going to get a migraine headache even if you're exposed to these triggers. So, let me now write down some of these triggers. So, a lot of them are similar to the ones that we saw in tension type headaches. So, firstly, emotional stress. Emotional stress, having a very stressful day, can then trigger someone with migraine to suffer from a migraine headache. Then the other 2 that we saw underneath emotional stress for tension type headaches, fasting is also a trigger. Sleep deprivation, again, is a trigger. All of these forms of stress on the body, these can all trigger migraine headaches. And then I'm going to add a few more that we haven't previously seen, which is physical strain, which means doing more exercise than your body is used to, so straining your body physically by doing more exercise than it's used to. That can also trigger someone with migraine to actually suffer from a migraine headache. And finally, the final very well-respected trigger of migraine headaches is certain foods and drinks. So, foods and drinks. Now, the 2 absolutely classic ones that everyone knows about are red wine and cheese. Those are the 2 that are very, very famous, but there are other foods and drinks. The one that I would put on here as a biggie is alcohol. Alcohol can trigger migraine headaches in people susceptible. Right, okay, so there is the basic introduction to migraine headaches. We've now done a description of what a migraine headache is like. We've done a description of the preceding aura, and I hope that you do have a basic understanding of what this is about now. The most common type of aura is a visual aura, but half of the people with visual auras will have an accompanying sensory aura. Very, very rarely people can have motor auras, and if they're suffering from migraine with motor aura, they usually have one of these very simple genetic forms of migraine, familial hemiplegic migraine. We've also discussed now the triggers for migraine headaches in those that are susceptible. In the next video, we will explore, or begin to explore, the pathophysiology underlying migraine and underlying migraine headaches. And to do that, we need to know about the meninges. We need to know a bit more anatomy. So we're going to actually have another break to go into a bit of the background anatomy. We will look at the background anatomy of the meninges, we're going to look at their innervation by nociceptors, and we're also going to have a look at the blood vessels, the blood supply to the brain, which a lot of them which run in the subarachnoid space. So we'll do that in the next video, a bit of background.